Hello friends, welcome to VK Lectures. In this lecture, we are going to discuss about complex integration part 1. Here we have the integral from a to b f of x dx. This is a line integral along a line of the function f of x. Now when you come to the complex number z equal to a to b, f of z dz, this a and b are complex numbers. It's also line integral along the curve connecting a and b. Now if this f of z, this particular f of z is analytical, then it is independent of the curve. No matter what is the curve, integral from a to b f of z dz will be independent of the curve, and it depends only on the end points, which is a and b, and this would happen only if this f of z is analytical. Evaluate the integral from z equal to 0 to z equal to 1 plus I. The f of x or f of z is x square minus iy dz. Now two questions are there. We have to find the integral along y equal to x, this is the one curve, and also along y equal to x square. Now let's start with y, the question, that is a, the value of the integral along this y equal to x. Now if y equal to x, dy equal to dx. Now we also know that z is equal to x plus iy, which means dz is equal to dx plus I dy. Now in this dy we will replace it with dx because dy equal to dx, so dz will be equal to dx plus I dy, I instead of dy dx, so that's equal to dx into 1 plus I is nothing but the dz. Okay, now we need z equal to 0 to z equal to 1 plus I. We are writing it in terms of x, so z starts from 0 to 1 plus I. Here x value is 0, here x value is 1. So when z changes from 0 to 1 plus I, the value of x changes from 0 to 1. So we can rearrange or rewrite this integral use such as integral x equal to 0 to x equal to 1 x square minus I y equal to x, so x square minus ix dz, we have to replace it with dx into 1 plus I. So this is equal to integral from 0 to 1, 1 plus I can be taken out, x square minus ix times dx. Now 1 plus I out, x square integral is x cube by 3, that is from 0 to 1, minus I into x square by 2, that is from 0 to 1. So 1 plus I into, substitute for the x, that is 1 by 3, this is minus I, and again 1 by 2. So Now what we can do is multiply each term. So starting with 1, so this is equal to 1 plus I into 1 by 3 minus I by 2. So that gives us 1 times 1 by 3 is 1 by 3 minus I by 2 plus I by 3 plus I times I is minus 1, minus of minus plus, so 1 by 2. So the real term is 1 by 3 plus 1 by 2. Imaginary term is I by 3 minus I by 2. So this is 5 by 6, the real term, and the imaginary term is minus I by 6. So this is the integral. See here we have the equation y equal to x square, dy is equal to 2x dx. Okay, now again we can write z is equal to x plus iy, which means dz is equal to dx plus I instead of dy 2x dx. This gives us dz is equal to dx into 1 plus 2ix. So first part is over. Now our integral from z equal to 0 to z equal to 1 plus I x square minus iy times dz. This is the question. Now we also know that when from here z is equal to x plus iy, when z moves from 0 to 1, x value moves from again 0 to 1, sorry, this is 0 to 1 plus I, x is moving from 0 to 1, and take this as 0 plus 0i to 1 plus 1i. So this is x value 0 to 1. So this integral can be changed into x equal to 0 to x equal to 1 x square minus I y is equal to x square into dz. What is dz? That is dx into 1 plus 2ix. Now here you can either take x square common and then later multiply, but let us do the multiplication now. So that's equal to, let's multiply these two quantities. So x square into x1, that is x square. X square into 2ix is 2ix cube plus 2ix cube minus ix square, then minus I into I is plus I, x square into 2x cube, so plus 2x cube. Right, now this integral with respect to dx from 0 to 1. So each term we can take x cube by 3, again 2i into x to the power 4 by 4 minus I into x cube by 3 plus 2x to the power 4 by 4. Now this all integral limits from 0 to 1. 0 you need not consider because it's the lower limit, there is no other terms coming which gives us other value other than 0. So x cube, so 1 by 3 plus 2i 1 by 4 2i by 4 minus I by 3 plus 2 by 4. 1 by 3, this is 2 by 4 is 1 by 2 plus 1 by 2 plus I by 2 minus I by 3. This gives us 5 by 6 plus I by 6. Now from this you can understand that f of z that we were dealing with, f of z which is given as x square minus iy, is not analytic. If it was analytic, both the integral should have been the same answer. Here we have the second type, integral over c f of z dz, where c is the circle of with radius z minus x plus iy mod equal to r. This gives the magnitude and that is equal to r. Actually it is the mod. Okay, now some points over here, this is the r, then we can write now this is point is x plus I y. Okay, that's the center. Now what we can do is we can find z, that is equal to r e to the power I theta. So dz will be equal to r, this is dz with respect to d theta, so r e to the power I theta into I d theta, so that's equal to I r e to the power I theta d theta, that is the dz. So integral over f of z dz, you can replace dz by I r e to the power I theta d theta. Then the integration will become integral from now this theta varying from some points, let us say theta 1 to theta 2, f of theta d theta. Now let us understand what is clockwise and anti-clockwise integration. Now anti-clockwise means from this is 0, this is pi, this is pi by 2, this is 3 pi by 2. So anti-clockwise from 0 to pi, this is in this direction, anti-clockwise. Clockwise direction is just the opposite, clockwise. Okay, so anti-clockwise means from 0 to pi, and clockwise is in this direction. This is clockwise. So anti-clockwise direction means the theta 1. So if I write anti-clockwise, then the integration anti-clockwise from 0 to pi means theta 1 equal to 0 and theta 2 equal to pi. Clockwise means the theta 1 will become pi and theta 2 becomes 0. Similarly, if it is from pi to 3 pi by 2 or pi by 2 to pi, it all depends on whether it is integration is taken over clockwise or anti-clockwise direction. Here in general our complex number, the argument means the theta angle made by the complex point or the complex number. So for example, if this is the complex number, z is equal to x plus iy, this is the argument, and this is with respect to, argument is with respect to x-axis or the real axis. So any integration or integral will be in default we will be taking it from in an anti-clockwise direction. In anti-clockwise direction, because theta is defined in that manner. Theta is from this point, how much is the angle made by this point z. Okay, now so let's write the same things. In upper half, this is the upper half above the x equal to 0 line. Now in the upper half, this is 0, this is pi, and this is again this bit 0, and this is 2 pi. So upper half means anti-clockwise. Generally it should be from 0 to pi. Lower half means it is from pi to 2 pi. Lower half means here, anti-clockwise direction. Now in the question, sometimes in the question it will be defined the integral value. Integration should be in clockwise direction. Integration in clockwise. In clockwise means just the opposite. Upper half means pi to 0. Lower half pi to 0 or pi to 2, pi to 0, and in the lower half it is from 0 to pi. Or you can take 0 to 2 pi to pi. Either this two things you can take, both are same, there will be no change. This is 0, this is pi by 2, this is pi, this is 3 pi by 2, and this is again 2 pi. Okay, now what is the value here? This point is where y equal to 0, that means x equal to 1. This is a point where x is 0, y is 1, that is I. This is a point where x equal to minus 1. This is a point where y equal to minus I. When I write the z, the complex number z equal to x plus iy, the values when z is equal to 1 means this is the point, that is 0, pi theta equal to 0. When z equal to say for example minus 1, which means theta equal to pi. When z equal to I, which means theta equal to pi by 2, and when z is equal to minus I, theta is equal to 3 pi by 2. Now this is the same thing, you can get it from e to the power I theta, which is equal to cos theta plus I sin theta. Then substitute the value for theta equal to 0, you will get this is equal to z equal to e to the power I theta. So put each value of z at theta equal to 0, theta equal to pi, theta equal to pi by 2, and theta equal to 3 pi by 2. You are going to get the values such as 1, minus 1, I, and minus I. Evaluate the integral along the curve C, z minus z square dz, where C is first one. We have to evaluate the first 1 and 2. Take the first one. C is upper half of the circle with z minus 2, mod z minus 2 equal to 3, which means the radius is equal to 3. Okay, now taking the first part, z is equal to r e to the power I theta, which means dz is equal to r e to the power I theta into I d theta. Okay, now what is r equal to? Radius equal to 3. So our z value is equal to 3 e to the power I theta, and dz is equal to 3 I e to the power I theta d theta. Okay, now the integral is along the curve C, z minus z square dz. Now that's equal to, let's write here, integral z is 3 e to the power I theta minus z square will be equal to 9 e to the power 2 I theta. This one into dz. What is dz? 3i e to the power I theta, 3i e to the power I theta d theta. So that's equal to 3 times 3, that is 9 I e to the power I theta, 9 I e to the power 2 I theta d theta, minus this is 27 times e to the power 3 I theta here one more I is there. Okay, d theta. Okay, that's accounts for the two terms. Now integral 9i times e to the power 2i theta, this integral is 2 to the power I theta by 2i, that is the integral of the first term. Then this value is from let's put the limits later. Then minus plus minus 27i e to the power 3i theta divided by 3i again. Now what is the limit? Upper half of the circle. Upper half of the circle means you can take from 0 to pi, 0 to pi, which means it is in anti-clockwise. If it is not given in the question, you should always go with anti-clockwise, because your z value starts from in this direction. The angle we will be talking is theta. It will be with respect to x coordinates. That's why it starts from anti-clockwise. Okay, so it is from 0 to pi, again 0 to pi. Now here first term we can go with the upper limit first. 9 I and I gets cancelled, so 9 by 2 into first let us put the upper limit 2i pi. 2i pi means 0, so that is 1. Why? E to the power I theta means cos theta plus I sin theta. Theta term is pi is sine term goes to 0, so cos 2 pi is 1. So 1 minus again the terms gives us e to the power 0, so again 1 minus 1 plus 27 by 3 is 9, so minus 9 into go to the upper limit e to the power 3i theta, so it becomes cos pi, that is minus 1. Again here with 0, so that's again minus 1. So this term goes to 0, and here we have minus 9 into minus 2, that is 18. So changing the limits here, the integration will be constant. The limits will vary, so it starts from, so here we have lower half of the circle, lower half of the circle, that is z minus x plus iy equal to 3. Now lower half means the integral value limits are from anti-clockwise in lower half is from pi to 2 pi. So let's change this limits. So 9i e to the power 2i theta by 2i from pi to 2 pi minus this one can be written as 9i e to the power 3i theta from pi to 2 pi. So 9 by 2 e to the power 4i pi, e to the power 4i pi minus e to the power 2i pi minus this one, there won't be I, so 9 into upper limit is e to the power 6i pi minus e to the power 3i pi. The first term e to the power 4 pi and 2 pi gives 0, minus 9 into first term goes to e to the power 6, so that is 1, e to the power 3i pi is minus 1, so that's equal to minus into 9 into 2, that is minus 18. Integral 2z plus 3 by z dz. The integral value is to be taken from in the clockwise direction in the upper half of this circle. Circle is given as mod z equal to 2. So in general, what is the formula for circle? Z minus x plus iy equal to r, where this is the center. Now in this case the center is 0. Okay, so z is equal to 2, the radius, e to the power I theta. Dz will be equal to 2 I e to the power I theta d theta. Okay. Now the integral 2z plus 3 divided by z dz. Now substitute for what is z. So integral, and also we can write the limit since it is in the upper half clockwise. It is from pi to 0. So pi to 0, z is 2 into 2 e to the power I theta divided by plus 3 into 2 e to the power I theta. Now we need dz. Dz is 2i e to the power I theta d theta. Okay, whichever is possible you can remove. Here we have 2 e to the power I theta, 2 e to the power I theta. So integral from pi to 0, 2 times 4 e to the power I theta d theta plus I is missing, so I times 4, then 3i, okay, 3i, that is integral 3i d theta. Both the integrals are from pi to 0. Now 4i e to the power I theta, integral is e to the power I theta divided by I from pi to 0 plus 3i theta from pi to 0. Now I gets cancelled. 4 times e to the power I theta, putting the upper limit first, e to the power 0, that is 1, e to the power I pi, that is minus 1, so 1 minus 1 plus 3i 0 minus pi. So 4 times 2, that is 8, minus pi into 3i, that is minus 3i pi. Integral over c mod z dz. It is in the left half of the circle. That means this is y-axis, this is x. So left half of the circle means this is the area where to the left of y-axis, that is x equal to 0 axis. Now from minus I to plus I, so this is minus I, this is plus I. This is 0, this is pi by 2, this is pi, 3 pi by 2, and this is 2 pi. And if you substitute for e to the power I theta, that's equal to cos theta plus I sin theta. So substitute for the theta value here, you will get the value of z equal to e to the power I theta. Now coming to what is z, the mod z, here the value is given mod z equal to 1, which means r e to the power I theta. So r value is 1, so e to the power I theta. Now dz is equal to e to the power I theta I d theta. So integral mod z dz, so mod z equal to 1, then dz will be equal to e to the power I theta I d theta, e to the power I theta I d theta. Now we want the limits of the integral. So it's given as minus I to plus I. So minus I means 3 pi by 2, plus I is pi by 2. So integral is I times e to the power I theta by I from 3 pi by 2 to pi by 2. Now that's also tells us e to the power I theta from 3 pi by 2 to pi by 2. Substituting the upper limit, e to the power I pi by 2 minus e to the power 3i pi by 2. So e to the power I pi by 2 is I, that is plus I, minus e to the power I 3i pi by 2 is here minus I. So plus I minus minus I, this gives us 2i. So integral is 2i. Integral or C log z dz along a circle with the mod z equal to 1. Now let's start with what is z. Z is equal to r e to the power I theta, which means r is equal to 1, which implies z is equal to e to the power I theta. So dz will be equal to e to the power I theta times I d theta. Now the integral, now integral is from along this curve, that means along the circle. So you can take the integral from 0 to 2 pi the log z dz, that's equal to integral from 0 to pi log of z is e to the power I theta times dz is e to the power I theta I d theta. So log e to the power I theta is I theta, so that's equal to integral from, this is 2 pi 0 to 2 pi I theta times e to the power I theta I d theta. So that's equal to minus 1 integral from 0 to 2 pi e to the power I theta or theta e to the power I theta d theta. Now we can write theta e to the power I theta. So this is integration. So let's take this is u v integration. Now let's take u as theta and v as e to the power I theta. So theta e to the power I theta. First derivative is 1, second derivative is 0. E to the power I theta, first integral is e to the power I theta by I. Second integral is e to the power I theta by minus I into I, that is minus 1. So this is plus, this is minus. So integration is theta e to the power I theta by I, minus of minus plus e to the power I theta. Now substituting the limits, theta e to the power I theta by I from 0 to 2 pi plus e to the power I theta from 0 to 2 pi. So first one, going with the upper limit, 2 pi by I, 2 pi e to the power I times 2 pi, that is cos 2 pi, that is 1, minus 0 plus e to the power 2 pi is 1, 1 minus e to the power 0 is again 1. So that's it. So here this is the second term is 0. This means 2 pi by I, dividing and multiplying by I on both sides, you get I here, so minus 2 pi I. Yeah, here minus 2 pi I, here is a term minus 1 which we have to add with this minus. So this is minus 2 pi I into minus 1, that's equal to 2 pi